Hi, welcome back to the lecture series on microeconomics. After finishing production function and cost functions, now we are in the last phase of theory of firm, where we are going to study how to find equilibrium output of a firm in short run and long run. So, before we study a firm's equilibrium in short run and in long run in the case of a competitive industry, let us first write down a firm's profit maximization problem once again to derive important first order and second order conditions. So, we write profit as pi and R is basically my revenue. Revenue is a function of quantity produced by the firm, of course, minus the cost, which is also a function of the output level Q, right. Okay. So, now we know we need to maximize profit. To maximize profit, we need to take derivative with respect to output level, and we get expressions like R prime Q minus C prime Q. Now, we know this particular entity, that is basically the marginal cost of production, right. Now, there is a new entity that we have just introduced, R prime Q. What is this? This is known as marginal revenue . What is marginal revenue? By marginal revenue, we mean that if the firm produces one more unit of output, how much extra it earns in terms of rupee or dollars for that additional unit of output. Now, we do not assume whether the firm is selling its product in a competitive market or in a non-competitive market. So, we will discuss these complications later on. Let us have a very simple model as of now. So, now let us look at the first order and second order conditions. So, the first order condition can be obtained after setting this d pi dq equal to 0, and that leads to this condition MR equal to MC, right. So, this is a very important first order condition that we are going to utilize heavily in the theory of markets. Now, to find the second order condition, we have to differentiate again, and we have to find out d square pi dq square, right, and we know that that has to be less than 0 for the profit maximization problem. Now, that means that R double prime Q shall be less than C double prime Q, right. So, in simple words, that means rate of change in marginal revenue shall be less than rate of change in marginal cost. This has very important implication in theory of markets. We will revisit this again. So, we have derived the firm's optimization conditions for profit maximization problem mathematically, but what is the intuition? Let us look at that MR equal to MC first order condition and the second order condition, but this time intuitively. So, what if we deviate from the MR equal to MC point? So, to understand the implication of that deviation, first let us understand what is exactly happening at the firm's equilibrium where MR equal to MC. So, at farm's equilibrium, where the farm is producing its equilibrium output level, for that particular output level the cost that the farm incurs is totally obtained by selling the product in the market. So, basically the extra dollars or extra rupee in that the farm earns in terms of revenue from selling this additional unit in the market is exactly equal to the cost of producing that very unit of the output. Now, let us see what if we deviate from that condition. Suppose we take this case of MR greater than equal to MC. What does that mean? That means that if the farm is producing some output level, for that particular output unit the farm is earning more by selling it in the market than the cost the farm incurs to produce that very unit. So, now let us go to the other side of the problem. So, if now the farm observes MC greater than equal to MR, then what happens? So, in this case, to produce that very unit of output, the farm spends more than actually it receives by selling that very unit in the market. So, in that case the farm will not produce that unit of output because it is making loss. But in the previous case, which is basically MR greater than MC case, there the farm is in a winning situation because by producing that extra unit of output the farm actually makes money. So, in both the cases farm will not be happy with its current output production level. So, in the first case farm will increase the production of output, and in the second case the farm will reduce its output production, and eventually the farm will hit back the old equilibrium point, which is basically denoted by or characterized by MR equal to MC, the first order condition. Now, let us look at the implication of these first order and second order conditions when the farm is part of a competitive industry. What is a competitive industry? So, first we have to understand what is an industry. So, an industry consists of many farms which produce the same good or service. So, a perfectly competitive industry is characterized by two features. First, the farm is a price taker. An individual farm's decision to produce one unit more or less of its output does not have any influence on the market price. And the second feature is basically the feature of free entry and free exit. That means that if the person waiting outside the market decides to enter the market, opens up a new farm and starts selling in the market, nobody can stop him. And if the individual does not like the business, he or she can always easily exit the market. There is no restriction on either entry or exit. So, if any farm satisfies these two characteristics or feature, that farm is a competitive farm from a producer's perspective. Now, let us look how these first order conditions and second order conditions that we have just derived has different interpretations for a competitive farm. So, here we are going to distinguish between short run and long run. We are going to study the short run equilibrium of a farm in today's lecture. Okay. So, here we assume that our farm is a price taker. Assume that our representative farm is a price taker. It implies that if there is a market price P bar, then the farm is selling its output at this particular P bar, which is beyond its control. So, this is a fixed price. Okay. So, our profit maximization problem in that case. So let me rewrite the profit expression again. So in that case it will be P bar, the fixed price that the firm earns by selling one particular unit of output, times the output being produced, that is Q, minus the cost of producing output, right. So now how my first order and second order conditions? So let me write SOC here, okay, forgot that. So now let us look at the first order and second order conditions in this case. So we will revisit what we have done earlier, right. So in this case from equation number 1 we can see that we have P bar minus C prime Q, right, and we need to equate that equal to 0. So finally we get what? We get P equal to marginal cost, right. But note that this is also equal to marginal revenue, because here the competitive firm is selling each and every unit of output it produces at a fixed price P bar. So the additional revenue it earns by selling an additional unit of output is P bar. So that is basically equal to marginal revenue, right. Okay. So now let us look at the second order condition. So for second order condition we have to have d square pi dq square negative, right, we have to have that condition. What does that mean? Now note that here, please note this second order condition that we have derived, let me call this 2, okay. So from here we can very well see that this R double prime, which is basically the rate of change in marginal revenue, will be 0 in this case, because here marginal revenue is constant, that is basically the market price P bar, right, that should be less than equal to C double prime Q. That indicates that my slope of marginal cost curve shall be positive, right. So this is also a very important result from the perspective of theory of firm. So that means that the firm's profit maximization problem will reach a solution when the firm is operating on the upward sloping segment of the marginal cost curve. This is also very important. Let us now look at a diagram to understand the first order and second order conditions of a short run equilibrium of a competitive firm. Okay, so we measure output produced by the competitive firm along the horizontal axis, and we measure marginal revenue and marginal cost along the vertical axis, right. Okay. So drawing a marginal revenue curve in this case is very simple. It is going to be line parallel to the Q axis, because marginal revenue in a competitive firm case is basically the market price, right. So let me denote this as my MR curve. Okay. So now the second order condition and the first order condition, if I want to draw in this diagram, I need to now draw the upward sloping segment of a marginal cost curve. So you would remember that marginal cost curve is basically an U-shaped curve. So first it falls, then it reaches an absolute bottom, and then from minimum point, there is an inflection point, it starts to rise, right. So in this competitive industry case, this part which I have drawn as the downward sloping segment of the marginal cost curve as a broken line does not exist, and we get an upward sloping segment of the marginal cost curve, right. So, if I assume an U-shaped marginal cost curve, then there will be two intersections, right, here one and then along the upward sloping segment. So, this point say A and this point say B. Now, I am saying that the A point is although meeting the first order condition, but it does not satisfy the second order condition. So, this is ruled out, right, whereas the case of point B satisfies both the first order and second order condition, and hence at this intersection point B the firm maximizes profit and it solves for the output level Q star at which this profit is maximized. So, now we have seen how this firm actually maximizes profit and finds the equilibrium output level given a market price. Now, note that this first order condition is the solution that we have just obtained is dependent on the parameter in the model, which is basically market price. So, if now market price increases to say P dash, then in that case there is a new equilibrium obtained, right. So, at point C first order and second order conditions both are satisfied, and if we now draw a perpendicular from this equilibrium point to on the output axis, we get another output level Q dash, which is profit maximizing at that particular price level. So, what we see? We see that there is a positive relationship between the market price and the firm's supply in the market. As market price rises, firm tends to produce and supply more for a competitive industry. But does it mean that the firm supply curve actually is the upward sloping segment of the marginal cost curve? Wait, we will find out the answer very soon. So, let us now have a diagrammatic exercise to find out firm's short run supply function. So, we are going to revisit the diagram that we have drawn while we analyze the short run cost curves. So, now we are going to revisit the short run average cost, average variable cost and short run marginal cost curves, and we will see the use of these curves in determining firm's short run supply curve. Okay. So, here is the diagram. Here I start by saying that although the complete diagram has an U-shaped short run marginal cost curve, but as we have seen in the perfectly competitive firm's case, the second order condition rules out this falling part of the short run marginal cost curve. We can ignore that. So, I can erase this from the graph to make it clean. Now, let us start with some initial market price O. So, suppose there is origin here, okay, and I start with the market price which is pretty high to start with, and say that market price is set at OP bar. Okay. So, if that is the case, then let me draw a parallel line parallel to the quantity axis, and you can see that at this particular intersection point firm's equilibrium, say this is point A. Okay. So, at this point A firm's equilibrium is obtained and the firm basically produces output level Q star, no, let me call it Q bar. Okay. So, firm produces Q bar level of output as equilibrium output level given market price P bar, Now let us look at another price which is lower compared to the initial price P bar, and let that price be here at P dash. Okay. And to find the firm's equilibrium, again we have to draw a straight line parallel to the q axis. So the firm meets its first order condition at this point B, and the firm solves for the equilibrium output level, because at this point B MR equal to MC condition is met, and the firm solves for this output level Q prime, say. Okay. Now note the difference between the first case and the second case. So let us find firm's profit in the first case. So when P equal to P bar and Q equal to Q bar, then firm's revenue R is basically the area O P bar A Q bar, right? And what is the cost of production in that case? The cost of production would be determined by the short run average cost curve. So the unit cost, right? So basically to produce Q bar level of output, we have to see how much per unit cost of production firm incurs, and that can be determined from the intersection of this vertical line A Q bar and the short run average cost curve. So basically I have to read the short run average cost value from the short run average cost curve for that particular output level, and then let me say that this is point C, and we are talking about some short run average cost curve, some short run average cost level SAC bar, right. So basically here in this case we get this area O SAC bar, then this point C, and then finally Q bar, right. So in this case you can see the firm is making a positive profit because the revenue is higher than the cost the firm incurs, right. Okay. So here there is no problem, firm will of course produce and supply Q bar units of output in the market. So now let us look at the case where the firm is experiencing a lower market price P dash. What happens then? So at this market price P bar, the firm finds equilibrium at point B, and firm decides to produce at Q bar level, QQ dash output level, because you know at point B MR equal to MC and both the first order and second order conditions are met, and mathematics tells the firm to produce at Q dash level. Now let us look at the economics of it, okay, and let us see whether the firm will be happy by producing here. So now if I want to find out the profit, so when P equals P dash, then Q is equal to Q dash as per my first order and second order conditions. But let us now look at the revenue. So the revenue in this case will be O P prime B and Q prime. Now what about the cost? So we will adopt the same trick. So we have to now go to my short run average cost curve and read the number from that curve, which will give me the unit cost of production at that level of output. So basically I have to basically extend that perpendicular line till that perpendicular line at Q prime level of output, till that perpendicular line meets the short run average cost curve, and then we see from the axis I can get the short run average cost of production at that output level. Let us denote that level of unit cost of production by SAC prime. So in that case we know that this is the cost of production. So let me denote this point as D. So this is right. Okay. So now here we can see that the firm is making loss because the total cost of production is actually higher than the revenue that it earns. So in this case, of course, the firm earns a negative profit, right. So should the firm make any production if it suffers loss? That is the next question that we would like to answer. Okay. So now let us study whether the firm will continue to produce if it experiences loss in short run. So now we are going to introduce two concepts which are very interesting, the concepts of break even point and shutdown point. First we will start by looking at the concept break even point. So note that on the short run average cost curve there is a point where the firm actually earns 0 profit, and what that point would be. So if a firm faces a market price which is exactly equal to the minimum point of the short run average cost curve, then basically the total cost of production would be exactly equal to the total revenue that the firm earns by selling its output in the market. So that point is known as the break even point. Let us locate that point in the graph. So now here you will see that I have cleaned up the graph quite a bit to make it look less clumsy. So basically we are talking about a price level. I need to erase this SAC. So now we talk about some market price, say P1, and let me denote this minimum point of the short run average cost curve as E1, and note that here at this point E1 my first order condition and second order condition are both met, because we know that the marginal cost curve passes through the short run average cost curve, right. So here the firm will find its equilibrium and the firm will produce Q1 level of output, right. So this particular point, which is the minimum point of the short run average cost curve, is known as firm's break even point. Because the firm makes 0 profit at this point. So at break even point, price is equal to minimum value of short run average cost curve, right. Okay. Now we are going to study the case where firm is going to shut down its production. So already we have seen that if the market price is low, like we have seen in the case of market price P prime, then the firm makes a loss. Now the question is that how much loss the firm is willing to suffer to stay in the business in the short run. So let us have a look at the diagram to answer the question. So here we see that there is a market price at which farm will be exactly able to cover its variable cost of production, because fixed cost is independent of the output being produced by the farm, right. So, the fixed cost that the farm has made is already gone. So, now the farm will try to cover at least the variable cost in the short run, right. Let us say that there is a market price P naught. Now, the P naught is basically a market price such that if I plot it in the diagram, the parallel market price line will pass through the minimum point of the short run average variable cost curve. So, I am now please pay attention to this point. So, here basically the farm is meeting its first order conditions and the second order condition for short run profit maximization, and that mathematics will dictate it to produce Q naught level of output. Now, note that if the firm decides to produce Q naught level of output facing the market price P naught, then the firm is at least earning that much of revenue from the market by selling output to cover up its variable cost of production. So, what would be the variable cost of production in this case? It will be this area which currently I am marking by dots, right. So, this area is both the revenue that the firm earns by selling Q naught output level at P naught price in the market, and this is exactly the variable cost that it incurs to produce that level of output. So, fixed cost it will treat as foregone and it will stay in the business with the hope that in near future market price will improve and the firm will be able to gain some profit in the long run. It will stay in the business because at least it is covering the variable cost that is currently being incurred by the firm to produce the output. So, now this point is known as the shutdown point of the firm. So, the condition to obtain shutdown point of a firm is this: price has to be equal to the minimum short run average variable cost, right. So, we will continue with the discussion in the next lecture.